Good day, all of you. Welcome to Electrical Testing 1 Lab. Today, in this session, I will be explaining experiment 2, which is from circuits part C2. Okay, so in experiment 2, I will be explaining you about the theorems of electric circuits analysis, superposition, Thevenin's theorem. Maximum power transfer we will not see in this semester. Okay. So we will see superposition and also we will see the Thevenin's theorem. So let us begin with what is superposition theorem. Yeah, superposition which states that in any linear circuit containing multiple independent sources, the current or voltage at any point may be calculated as the algebraic sum of the individual contribution effect of each source acting alone. It means that uh, the superposition principle states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltages across or currents through that element due to each independent source acting alone. Superposition theorem determines the contribution of each independent source to the variable and then add them up. A linear circuit is one whose output is linearly related or directly proportional to its input. So we will do three steps here. First step for example, let's go to the next slide. Yeah, here this is the objective experiment that we'll see what is superposition theorem and to apply Thevenin's theorem. And then I'll be showing you how our power supply can be used here. Okay, and multimeters. These are the apparatus required and group of resistance 330 ohms and 220 ohms, potentiometer 470 ohms. Now this is the circuit diagram. I've shown that according to this, you see we are using two power sources. Okay, power source 1 and power source 2. Power source 2 is using 6 volts and power source 1 is 12 volts. So we will follow the three steps. First, we'll find out the current I naught. This I naught due to two sources, PS1 and PS2. Okay. Then second step, we'll find out I01 due to only one power source, PS1. Then what about PS2? It will be short circuit. Okay. So PS2 will be short circuit. And third step is, yeah, third step is we will find out I02 due to power source 2 only, in which PS1 will be short circuited. Okay. Then at end we'll verify the superposition theorem that I0 is equivalent to I01 plus I02. Okay. This is what the definition of superposition theorem. So before we go that, I'll just show you some slides which will help us in understanding. First, I'll show you the components. Yeah, this is the multimeter. We have components like 220, 330 ohms and all. So here you have a multimeter, And as you have seen that in our circuit diagram, we are using voltmeter and also we are using ammeter. Suppose if you are using it as a voltmeter, okay, so in the circuit, if you are using voltmeter, then this voltmeter has a positive terminal and a negative terminal. Okay, how you will use this multimeter as a meter? I think you see here voltmeter. V is written and ohm is also written. So this is, if you use this port, this is the positive terminal of the voltage, and this COM is ground, common or ground, negative terminal. Okay. Now suppose if you want to use this multimeter as a ammeter, then we can use either this milliampere or this ampere. Okay, so in all our experiments we are using in milliampere, so we'll use this. Okay, so in ammeter also, when you have an ammeter in a circuit, this ammeter also has a positive terminal and negative terminal. How do you know that this positive? This red is the positive terminal for ammeter, and again this is same, this is common for ammeter. Sorry, this is positive and this is negative or ground. Okay, so in this case we are using this as an ammeter, and in this case we are using it as a voltmeter. And make sure that when you are using this as a voltmeter, if you are using this as a voltmeter, then this should be pressed. Okay, it should be pressed. It should be pressed. If you are using this multimeter as a ammeter, then in this case this has to be pressed. Okay, and if you want to measure only the resistance, okay, then in that case we'll just press this button. Okay, this is just for measuring resistance. Okay, and here we have a screen which will give you the readings, and this is on or off button. You can either turn it on or off. Okay, this is for changing the range. So I hope you might have understood this. I hope you have understood the usage of multimeter. Now I'll show you the power supply. Yeah, this is our power supply. As you have seen that in our circuit we need two power supplies. One power supply PS1, which is 12 volts, and another supply PS2, which is 6 volts. Okay, so now when you just observe, just use red color. Okay, this area, okay, this is acting as a power supply. If you make this knob down, then it will work as a 12 volts. If you make it up, it will work as 15 volts. Okay, and this is the positive terminal for 12 or 15 volts. Okay, the positive terminal for 12 volt or 15 volt. Okay, and similarly you may have seen this knob. Okay, this knob is used to set a variable voltage from 0 to 12 volt. Okay, so this is the point, positive terminal for variable voltage from 0 to 12 volts. You can set any value by rotating this knob, and for both of them this is common, this is ground. Okay, negative terminal. and make sure that in this experiment we are using the PS1 as 12 volt. Okay, so this will be our PS1 power source 1, and this will be our power source 2, PS2. Okay, and make sure that you have to turn it on. Okay, this is off. When you turn it on, the light will be, green light will be blinking, it will be on. Okay, so turn on the power supply, turn on power supply. Okay, so after having understand this, now I will discuss that how to give connections all. Okay, so let me share the application with you. Yeah, so I'll just go. Now let us see the connections part of superposition theorem. Now let us see the connection part for the superposition theorem. Yeah, we have 330 ohm of resistance and 220 ohm of resistance and 150 kilo ohm of resistance. Sorry, 150 ohm of resistance as shown here in the diagram. We have three resistance and we have power supply 1 and power supply 2. Power supply 1 is 12 volts, power supply 2 is 6 volts. We'll get 12 volts from this knob by, and 6 volt by from this variable voltage power supply. So let us set this variable voltage volts to check. 1 minute. Yeah, is it working? Okay, check. Okay, so it's working fine. Yeah. So let us make this power supply 2 as 6 approximately volts. So this is acting as power supply 2, and this is power supply 1 by pressing this knob down, so that this red will become a power source of 12 volt. Now let us give the connection fastly. Okay. Yeah, see, from 12 volt we will give it to the 12 volt power supply. We are giving it to 330 ohm, from 330 to 220, and from this any one of this point to the 150 ohm, and this will connect to the power supply 2, which is 6 volts, which we have just set now. That's great. Now we will you know, 150 ohm is connected to the positive terminal of the ammeter. So 150 is connected to the positive terminal of the ammeter, and ammeter is grounded. We connect ammeter here. That's how we got two power supply, and due to the two power supplies, which is 12 volts and 5 volts, are connected. You see, let us see the connections once again, from PS1 to 330, 330 to 220 volts, and from 220 blue wire is going to PS1, PS2, which is 6 volts. Okay, and this is red wire is connected to the ammeter. We just remove this multimeter, which is of no use here. Yeah, this red is connected to, yeah, this ammeter. Yeah, this red wire is connected to the ammeter, and ammeter is grounded. Due to two power supplies, we got reading as 29.7. So we'll note it down. We got 29.7. So we just note it down. Now we will short circuit PS2 so that we can find the contribution of PS1 only to find the contribution for PS1, PS2 has to be short circuited. And similarly, next part, PS1 is short circuited to get the contribution of PS2. So to get the contribution of PS1, we first short circuit PS2. Then next we short circuit PS2, PS1 to get the contribution of PS2. Let us see now. I'm short circuiting PS2, 6 volt. So from the red, this is 6 volts. Okay, I remove it and connect it to the ground so that this gets short circuited. 6 volts get short circuited. So now only one power supply is connected, which is 12 volt. Due to this 12 volt PS1, the total current I01 is 17.0. Now similarly, I'll just now go back and connect back this power supply 6 volts, and now I will remove this 12 volt power supply and ground it. Yeah, and ground it, and let us see the contribution of only I02, which is due to PS2 is 12.7 volt, which we will document here. Okay, 12.7 volt. Okay, so this is how we take the readings. So okay, now here we just measure the values due to I naught. Just you note down here, this is, yeah, this is 29.7 milliampere. And then next we will find out the current due to PS1, and we just short circuit PS2. Okay, so here we got 17, and next I02, that is the current due to only PS2. So we will short circuit PS1. So only due to PS2 you got 12.7. Okay, this is what we have got. Now according to the superposition theorem, which states that I0 is equal to, okay, I0 is equal to 29.7, but what is I01? It is 17, and I02 is 12.7. If you add both I01, I01 plus I02, which is give you 29.7, which is equal to I0. Okay, thus we have proved the superposition theorem. And next thing is you have to do calculations. So please see, this is measured, but this is not measured. Please correct, this is, here you have to write the calculated values. Okay, calculated values. Okay, so you have to write the calculated values here. How you will do, just I'll show you. Yeah, how do you do the calculations? Just I'll show you. Yeah, yeah, here in this diagram, what you have to do is, first you have to find out uh, I naught. Okay, using I naught due to two sources. This is your PS1 power supply 1, and this is your power supply 2. Okay, so just find out, and then next you have to draw the circuit, plus minus, only due to PS1 12 volts. Okay, you have this 330 ohms, 220 ohms, and you just short circuit it. Okay, and so you have 330 and 220 is this is I01. Okay, now you just find out I01 is how much. Okay, then next you have to find out I02. How? Now this time you will short circuit this 12 volt 330 to 20. Okay, and here you will have RL, and here you will have 6 volts, 220 ohms, and 330 ohms. This is RL, and with this you have to find out I02, and at end you need to verify that I01 plus I02 will give you I0. Okay, this is, you will get calculated values. Okay, this is about the calculation. So hope you have agreed, you have understood. Okay, now the next part is we will see the Thevenin's theorem. Okay, so let us see what is Thevenin's theorem. We will see the Thevenin's theorem. Okay, so let us see what is Thevenin's theorem. Yeah, this Thevenin's theorem, it says that for any two-port linear network can be reached by equivalent independent voltage source in series with a resistance. The source voltage is the open circuit voltage between the two port, and the resistance is the equivalent resistance seen between the two port, with all the independent voltage sources replaced by short circuit and independent current sources replaced by open circuit. Okay, so whatever may be is the two port network. Okay, you can just convert this into just finding the VThevenin voltage across the entire two port network, and connecting this load, finding the RThevenin, which I will show you in the experiment how do we do that. Okay, and connecting this RThevenin in series with the load resistance. Okay, so this complex network. Now let us see the connection part for Thevenin's theorem. As shown here, in the Thevenin's theorem, we have to find out first VThevenin and then RThevenin. Then we'll note down the value of VThevenin and RThevenin. And according to the theorem, it states that the equivalent circuit can be found for a two-port network, in which VThevenin can be kept in series with the RThevenin, which in turn in series with the RL. So here we'll just give the connections. See, from 6 volts variable voltage per supply, I'm giving it to 330 ohms, and then from 330 ohms it goes to 220 ohms. Actually, I should give it from 12 volts. Please correct it. 12 volts to this resistor, and from resistor to. And here, as usual, this is power supply 2. So we have connected two sources. Okay, and we need to find out the voltage now. Okay, across these points, this, and we just connect. Yeah, here we see we connected PS2 to 230 ohms, and PS1 is 220 ohms. We have not connected any resistor here. Here, either this or this point, both are common points. From there to ground, I will connect the voltmeter. So to get the VThevenin value. So here VThevenin, yeah, it is showing that it's 10 volts when we connect the voltmeter. So we got the value as 10 volts. Now note down that this value is 10 volts. We will find out now RThevenin. In RThevenin, we have to just change this from volt to ohm, and just we'll change the range because it is overflow exceeding the range. So we set the range according to it, and let us give the connections as shown here in this Yeah, here we connect 330 ohm and 220 ohms, and then we'll find out the equivalent resistance. Okay, using the ohm meter. How we'll do? It's very simple. See, we connected 330 ohms and 220 ohms, and they are connected back. Now we have to just find out the equivalent resistance. How we'll find out the equivalent resistance? I'll connect the ohm meter just now. We will just connect to the two endpoints, and this black wire connect to. So it's giving me 131.4. Okay, as see, we have connected this red wire here and black wire here. So it's giving me the equivalent resistance of 131.4. So this is our R Thevenin. So let's look the connections again. It's very simple. Okay, so let us note down R Thevenin as 131.4. Now what we have to do is, we got V Thevenin as 10 volts and we got R Thevenin as 131.4. Now it's very simple that we have to take a potentiometer and set its resistance to 131.4 as we are doing here. Okay, we just check using potentiometer. This is our potentiometer, which is of 470. This potentiometer, which is of 470 ohm. Okay, because I need to set 131, which is less than 470, so I can use this potentiometer. Okay, we'll connect one point at the top right and another is the bottom, and we'll use this knob to set the resistance to 131.4. So we should be very careful in doing that. A small touch may make a lot of difference. So let's take approximately this 131.5 or 4. Okay, so now we'll remove this plug points and make sure that you don't touch it because we have set it already to 131.4. This is your R Thevenin. So now according to the circuit diagram, it says that V Thevenin, which we want it to be 10 volts, which we'll set with the help of variable voltage power supply, and R Thevenin with the help of potentiometer, we make it as 131.4. So we'll give connections according to the circuit. So let us first set 10 volts. So 10 volts, we'll set 10 volts, make it a voltmeter, and make it 10, so that our power supply VThevenin is ready. Now we have to turn it on. See, this is not on. Okay, if it is not on, if you change also, it will not give you any value because it is turned off. So now when you turn it on, now it starts giving you the correct values. So make sure that power supply is turned on and set it to VThevenin, which is equivalent to 10 volts. Yeah, so we got VThevenin. Great. So now let us give the connections. We'll remove all other components and give the connections in such a way as shown in the step 3. VThevenin is connected to R Thevenin and the load resistance. Instead of 220, I will take 150. Okay. So let us see that. Okay, let me check, is it recording? Yeah, it is. So from VThevenin I connected to R Thevenin. Okay, then from R Thevenin is connected to the load resistance of 150. So from this bottom point we connect it to here. Okay, then RL, it is grounded. So yeah, this RL it has to be connected to the ammeter, then ammeter is grounded. Okay, so we'll remove these unnecessary components to avoid confusion, and we notice that after giving this connection from VThevenin to R Thevenin, and from R Thevenin we give it to load resistance is connected to the ammeter is grounded. Okay, and we got the value we set it to 10 volts, which is VThevenin. Okay, so now we will see the value that what is the current we got is 35.6. Okay, 35.6. So let us note down this value, 35.6. Okay, now I'll show you the things now. Let's go back and I will share the screen. I will go to the file for doing calculations for Thevenin's. Yeah, let's go to page number, I think, for Thevenin's theorem. Yeah, this is let me just connect it accordingly. Yeah, this is our Thevenin's theorem. Okay, I'll just show you that what we have done. We have just noted down that we got the 10 volts of VThevenin and 131.4 ohms, and we connected this VThevenin. We set VThevenin to 10 volt. Okay, using multimeter, and this is nothing but your 131.4 ohms, and instead of 220 I take 150. Okay, and so that we connect this the other point to the ammeter positive terminal. This negative is grounded. Okay, so now we'll measure the I naught. We saw that I naught we got as 35.6, which I will show you in the next slide. Yeah, here we get I naught as 35.6, okay, milliamperes. Now, how do you write this table? Here you got the VThevenin as 10 volts, and this is 131.4, and it is 35.6. This is the value. Now you have to find out the calculated values. How you will find out the calculated values? It's very simple. That for calculations, think here. Yeah. You see, you need to find out the VThevenin, okay, and you have to find out the RThevenin using the calculations, and take here RL is equal to 150 ohms, okay. Then you need to find out I naught. After getting these values, you have to update in the previous table the calculated values. Okay. Hope you have guys understood it. If you have any questions, you can ask. Okay, I'll stop here.